Have you ever looked up at the sky and seen a flock of birds flying in a perfect V shape? You probably wondered where they were going. For many birds, this isn't just a short trip. It's the beginning of an incredible journey that can span thousands of miles. How do they know which way to go? There are no signs in the sky and no maps to follow. To understand how amazing this is, think about the Arctic tern. This small bird is a champion traveler. Every year, it flies from its breeding grounds in the Arctic all the way to the Antarctic, and then back again. This round trip is about 44,000 miles long. That's like flying around the entire planet almost twice, every single year. They do this without getting lost, finding the same small patch of land year after year. Now, imagine you had to make a similar journey. What would you need? You'd probably start with a map or a GPS on your phone. Without these tools, most of us would be hopelessly lost in just a few hours. We rely on technology to tell us where north is, which road to take, and how far we have to go. Birds have none of that. So what's their secret? How do they perform these amazing feats of navigation? The hidden problem for a migrating bird is immense. They face powerful storms that can blow them off course, vast featureless oceans with no landmarks, and predators along the way. Yet, they navigate with pinpoint accuracy. Scientists have been fascinated by this for centuries, and what they've discovered is that birds don't have just one secret. They have a whole toolkit of natural abilities. They have a built-in compass, a clock, and even a map. This toolkit is so sophisticated, it's like having several different kinds of GPS systems working together. Let's explore these incredible natural tools, one by one. The first tool is one we see every day, the sun. Just like ancient sailors, many birds use the sun as a compass to get their bearings. During the day, they can determine their direction of flight by looking at the position of the sun in the sky. As we know, the sun rises in the east and sets in the west. An incredibly accurate internal clock, this biological clock, located in their brains, works just like a watch. It tells the bird what time of day it is. By combining the sun's position with their internal sense of time, they can always figure out which way is north, south, east, or west. Scientists tested this by placing migratory birds in a special circular cage where they could see the sun. The birds would always try to fly in the direction of their migration. Then, the scientists used mirrors to change the apparent position of the sun. The birds immediately changed their direction to match the new sun position. This proved they were using the sun to navigate. But what happens when the sun goes down or on a very cloudy day? Many birds migrate at night to avoid predators and the heat of the day. For these nighttime travelers, the sun is useless. So they switch to their second navigation tool, the stars. Just as they use the sun, nocturnal birds use the patterns of the stars to find their way. They don't need to know all the constellations, just one key area of the night sky. Birds that migrate in the northern hemisphere, for example, learn to recognize the stars that rotate around the North Star, Polaris. This point in the sky is the center of rotation, so it's a fixed point that always indicates true north. By keeping themselves oriented relative to this point, they can hold a steady course all night long. Researchers discovered this by putting night-migrating birds inside a planetarium. When the scientists projected a normal night sky, the birds oriented themselves for migration. But when the scientists rotated the star map, the birds changed their direction to follow the new north. It was clear evidence they were steering by starlight. The ability to use both the sun and stars is incredible. But birds have an even more mysterious and powerful tool in their toolkit. This tool works day or night, in clear skies or in thick fog. It's a sense that humans simply do not have. Birds can sense the Earth's magnetic field. Our planet acts like a giant bar magnet with a north and south pole. It's surrounded by an invisible magnetic field. This is why the needle on a compass always points north. Birds have a built-in magnetic compass. They can actually feel or see the lines of the magnetic field, giving them a constant sense of direction. How do they do this? Scientists believe it happens through a complex process in the bird's eyes. A special protein in their retina might allow them to visually perceive the magnetic field as a pattern of light or shade overlaid on their normal vision. Imagine being able to see glowing lines in the sky that always point you in the right direction. That might be what it's like to be a bird. This magnetic sense doesn't just tell them which way is north. The Earth's magnetic field also has other properties that birds can use. For example, the strength of the field and its angle relative to the Earth's surface change with latitude. The field is stronger at the poles and weaker at the equator. This means their magnetic sense might also work as a kind of map. By sensing these subtle changes, a bird can get an idea of how far north or south it is. This helps them know when they have arrived at their breeding or wintering grounds, even if it's a place they've never been before. It's passed down through their instincts. So birds have a sun compass, a star compass, and a magnetic compass. But the list of their amazing senses doesn't even stop there. Some scientists believe that birds also use their sense of smell to find their way, especially for the final part of their journey. Oceans, forests, and fields all have unique scents carried on the wind. A bird returning to its home territory might be able to navigate by following a familiar smell map. Homing pigeons, for example, are famous for their ability to find their way home. Studies have shown that when their sense of smell is temporarily blocked, their navigation skills are significantly worse. Finally, there is even evidence that birds can hear very low-frequency sounds known as infrasound. These sounds, which are too low for humans to hear, travel for hundreds or even thousands of miles. Things like waves crashing on a coastline, wind blowing over mountains, or even distant storms create unique sound signatures. Birds might use this soundscape as a giant audio map to guide them over long distances. So when you see a bird flying overhead, it's not just wandering. It is a master navigator, using a whole suite of senses we can barely imagine. It's not just one thing. It's the sun, the stars, the magnetic field, smells and sounds, all working together in a beautiful and complex system. If one system fails, like on a cloudy day when the sun isn't visible, they have backups. They can switch to their magnetic sense. If a solar storm disrupts the magnetic field, they might rely more on the stars or sounds. This redundancy is a brilliant piece of natural engineering. It makes their navigation system incredibly robust and reliable, ensuring they can complete their epic journeys against all odds. The world of science is full of these amazing discoveries, showing us that nature has often solved incredibly complex problems in the most elegant ways. The simple flight of a bird is powered by physics, biology, and a kind of planetary science that connects them to the sun, the stars, and the very core of the Earth itself. Next time you see a bird flying south for the winter, remember, you're not just watching an animal. You are watching one of the most sophisticated navigation systems on the planet in action.